First Take Math with Brian Thomas. We're going to continue today solving quadratic equations, and we're going to use the method of factoring. So we're going to use again this whole concept of setting equal to 0. Remember, with the linear equation we're trying to get x by itself. With the quadratic, the strategy is a little bit different. So the strategy we're going to incorporate is what they call factoring. So we have our quadratic equation, 5n squared plus 19n plus 12. Remember, this is the quadratic term. This is what makes the quadratic equation. This is our linear term, and this is our constant. Now again, since there's a coefficient in front of the n squared, the way to factor this thing is we like to use what's called the x factor strategy. So you draw your x on your paper. Your first move is you have to multiply the outer pieces together. So 5 times 12, that gives me 60. That slides into the x here. Our next move is just to slide the 19 into the problem, down below. So this creates our mama strategy, our multiply and add pieces. So the 60 goes over here, the 19 goes over here. Now our next move is to try to figure out what are our factors of 60. Well, we know 1 times 60 is 60. That's always our starting point. And we just proceed on down. 2 does go into 60, so we use 2 times 30. 3 goes into 60, that's 3 times 20. 4 goes into 60, I believe 4 times 15. That makes sense. 4 times 15. 5 goes into 60, 5 times 12. 6 times 10. A lot of factors for 60. Does 7 work? No. 8? No. 9? I don't see that either. 10's here. Now I can stop looking for factors. Our next move is now to go to the adding piece of 19. Which of these pairs adds up to 19? This 4 and 5 looks like that's our winner. 4 plus 15 rather. 4 plus 15 is our 19. So that passes our test. Oops. That gives us our 19. So that tells me that 4 times 15 is 60, and 4 plus 15 is 19. That now slides into these two spots of our x factor. So the 4 goes here, 15 slides over here. Our next move is then this 5 has to slide underneath the 4. That's where it gets a little tricky. So the 5 slides underneath, not only under the 4, but also it slides underneath the 15. Now these are going to be used for the answer, but these fractions have to be in what we call simplest form. 4/5 is in simplest form, but notice how I can divide each one of these by 5. So I need to reduce that to then 3 over 1. So now we have our factorization. And remember, it kind of goes from bottom to top. And our letter is n, so we have 5 times n plus 4 times the quantity. And again, we go from bottom to top, so 1n or n plus 3. And that is our factorization of 5n squared plus 19n plus 20. So all we're doing is rewriting this as a factorization. And remember, in terms of the rectangle, these were our edges of the rectangle. And these edges, in this case, have to equal 0. Our strategy is what makes this 0 and what makes this 0. I'm okay with this one, a -3, but that one's not so easy for me to see. So what I did is set it equal to 0. And I set this equal to 0. These now become linear equations, which means we want to get the n by itself. So we 0 pair out the 4. So I have 5n is equal to -4. We 0 out the -3. N equals -3. I'm still not finished this in though. I gotta get the n by itself. Kind of got in a hurry there. So we can divide each side by 5 to get n by itself. those n's, those 5s will divide out. N equals then a -4/5, and n equals a -3. We haven't done many with fractions, but a fraction is a number, and therefore our solution could be a fractional answer. So as a solution set, our solution would be a -4/5, and also we had a -3. What this means is, to satisfy this equation, if I put this number in for our n, it should make this turn to 0. Also, if you put a -3 in for n, that should also make that turn to 0. Try that on the calculator and see if you do get that to turn to 0. Okay. Stay tuned, we'll do